for the lab on water and its properties. So I'm just going to go through each activity and what would have been done had you been here, but what the data is going to tell you. So activity 1 is about intermolecular forces, and specifically you're looking at surface tension. Surface tension is literally the tension on the surface. So how hard would you have to push to break the surface? Things with high intermolecular forces have high surface tensions. It also has to do with drop size. So things with high surface tensions will stick to themselves better and they will form bigger drops. And so what we're going to do is we're going to put drops on a penny, drops of water, number of drops of water that a penny would hold. And I'll give you the data. And then you're going to do the same thing with soap. So you dip the penny in soap first. Now what soaps do is they will lower the surface tension of water. And so if they lower the surface tension, it doesn't stick to itself quite as well. All right, so that's activity 1. Activity 2 is called bending of water. I'm just going to call it Act 2. This is bending of water. And so what we would have done, and I think I can find a video or at least pictures, but I can at least tell you what happens, is it's going to have a stream of water. So this is water coming out of, let's say, a dropper. Right, so water's coming out of here. If you take a balloon and you rub it against, say, your head, what that does is it pulls electrons off of your clothing or off of your hair, and it will make the balloon negatively charged. So here's a balloon. Right. This is just the knot. And as you bring the balloon closer, let's do it the other way. What we would expect is that this will push the water over. So if I erase the water now, what we would expect is as the balloon comes, it'll bend the water. And so it'll typically bend it away, or it might bend it towards it. Right? So that's activity 2. Right? Activity 3, I don't know how I just made it smaller, but I'd like to learn how to do that regularly. Activity 3, you're going to put a bunch of ionic compounds, you're going to do like dissolves like. So activity 3 is just seeing what dissolves in what. So what you would have done is taken a little bit of things, various things, solute. If you look at the data, solvent. And we are going to look at various things and see what dissolves in what. So the first one would be alcohol and water. And alcohol is polar, water is also polar, right? And then if you look a couple further down, sugar and vegetable oil. And so when the slab is actually done, you take a very small amount of the solute and as much of this as you can. And you're just going to see what dissolves. And remember the idea that like dissolves like, which we talked about before. All right, so that's activity 3. Activity 4 we're going to do solubility of salts. So the word salt is an ionic compound. So ionic compounds should dissolve in water, but some of them don't. So an example of an ionic compound, NaCl, right? Calcium carbonate. Okay, and in the lecture you should have had some stuff about nomenclature. And in nomenclature, naming these things, not trivial. Right, but what you'll find is some ionic compounds dissolve in water and some do not, and it's actually based on experiment. And so what we would do in the experiment is add a very small amount, just enough that you could see if it doesn't dissolve, put it in water and see if it dissolves. All right, and so that's what you're going to find. Some things dissolve in water and some don't. All right, and then there's 2 more, 5 and 6. The nomenclature piece for this lab, I'm going to leave. I'm not going to talk about it here. I'm going to let you guys read that because there's a really good discussion of it in the lecture. And those of you who are in the lab who are not in lecture have had lectures, so you should be okay. All right, activity 5 is what you're going to do is you're going to take some detergents and some soaps and add calcium chloride to them. And so you're going to take some detergent soap, and I just showed you that on the previous video, plus calcium chloride and just soap and then you're going to add I'm sorry, and then you're going to do detergent. Plus, it says in the lab manual Epsom salts, but we would switch it to calcium chloride, right? Epsom salts, just by the way, the same thing as bath salts, except bath salts have pretty smells, so they add a perfume to it. It's magnesium sulfate. Okay, but what you should see is calcium ions with soaps, right? And detergents are sulfates. Right? And then the last one is activity 6. And activity 6 is conductivity. Conductivity, to conduct electricity, if there are charged particles, that can move. So in a wire, it's electrons. So you would expect sodium chloride, for example, sodium chloride, right, charged particles, but if it's a solid, you would expect it should be no conduction. But if we take sodium chloride in water, say it's in a big container full of water, this should conduct. And so you're just going to look at what conducts. Covalent compounds should not conduct because there's no charged particles. And so you're going to look at various things and just see if they conduct electricity. And what we'll do is we'll talk about if it conducts very strongly or very weakly. And strongly just means there's more ions. Weakly would mean there's less ions. Right? So I'll give you data for this, and good luck with it. I think it's a good lab, and I think even just giving the data will help a little bit.